Equation of a sphere. The sphere with center ABC and the radius r can be represented by the equation x minus a squared plus y minus b squared plus z minus c squared equals r squared. This is known as the standard equation of a sphere. So now the center being ABC here means that radius, when I go out to this surface, that's what my r is going to be. And that happens all the way around this, towards me, away from me. Any part on the surface are going to be all the same value that r. So now if we think about this on the XYZ plane, so just kind of placing it anywhere, I can see that my sphere on the XYZ plane here, that we'll be able to just kind of get an idea of where that center is at. So you know the center is not at 0, 0, 0. We can see that. And so I'm just going to develop the box idea so that you can kind of see what that's going to be. So if you see, I get a 5, a -5, and then a 3. Now what I'm going to do from here, we need the center, the A, B, and C, and we also need a radius here. So I'm just going to kind of draw these lines in there so you can kind of see what's happening with this. And when I take a look at this, you can see that I'm just kind of drawing these out so you can see where this radius is coming from. So it looks like that radius is going to be a 4. Because when you look at that, I go over this 1, this 2, this 3, and this 4. And that means my r then is going to be 4 here. And then now that we have all the information we need, we can actually write the equation for this specific sphere. Okay. So that's going to be x minus 5 squared plus y minus -5. So I'm going to say y plus 5 squared plus z minus 3 squared equals 4 squared, which is 16. So this would be the equation of this specific sphere. Now that's one way to use this equation here. Find the equation of a sphere whose center is 5, -5, 3 and contains the point 5, -9, 3. So what we're going to do is we're just going to use the same formula for this one here. So we know a point on the surface of the sphere, and we also know the center. So all we really have to do is just kind of plug it in here. So for the point on the sphere, we're just going to plug that in for this x, y, and z. Okay, so that's going to give us 5. Oh, hang on. Let me write the right ones. 5, yep. That's going to be my x. And then minus my 5, because that second 5 there is the center. That's my A. Okay. And then that's squared plus, and then now we're going to do the y minus b squared. So my y here is going to be -9 because that's the point on the graph. So -9 minus, and I'm going to do this 5 here. So I'm just going to say plus 5 squared. And then plus my z, and now we're here. So my z is going to be this 3 here because that's a point on my graph. So that's going to be 3 minus, and then I have this 3 here. And then close parentheses squared, and that equals r squared. Because we don't have an equation here. That's all we're given, so we can only use what we're given. Okay, so then I'm going to simplify this a little. So this here is going to give me 0. This also is going to give me 0 here. So I really end up with negative 4 squared equals r squared. And then that's going to be 16 equals r squared. And then I can say 4 equals r because if I square root both sides. Now be careful, when I square root both sides, I do get a plus and minus. But I'm just going to use the positive here because we're talking about a radius. So that's going to be 4. So I get the equation then, since I have the center already too. It's going to be x minus 5 squared plus y plus 5 squared plus z minus 3 squared equals, and r is 4, so 4 squared is going to be 16. And you notice that I'm dealing with the same sphere as I was previously. And you notice we should get the same equation. All I did was find a point on that sphere. And from there I was able to generate a different question, but still using the same equation. So there we go.